Hey guys, demo video for our assignment number 3. Let me get things settled here. Okay. I thought it was kind of cute that in the last video some of you thought that what you were supposed to do is submit what I did in the demo for a grade. That would be pretty cool because I do it for you and you just take a screenshot of what I did and get credit for it. It's got a little bit more to it than that. So let's make sure that we understand what's going on here. For our assignment number 3, the problems that I'm doing right now are just for demonstration. You're going to have our assignment number 3 with the due date will be listed in the title on Blackboard. I think the way it's going to work this particular semester that I'm posting this video, I think you're going to have somewhere 9 or 10 days, and that's usually the way I'm going to make these things happen. So anyway, guys, don't submit the problems for the demo that I'm doing for you. You're going to have a different assignment that you're going to submit, and you'll submit it via screenshots just like you've done the other ones. So guys, let's get going. Our assignment number 3 is by far, without question, the easiest R assignment that you'll have the entire semester. So so good for you. Okay. Now, what we're doing here, there are essentially 2 R codes that you will use, and one is called P-norm, and P-norm is going to remind you a lot of normal CDF on your calculator. The other command that you're going to have is called Q-norm. Q-norm will remind you a lot of inverse norm. So guys, this is going to work a lot like normal CDF on your calculator, and this one will work a lot like inverse norm on your calculator. Now there's going to be some changes, there's going to be some modifications. Actually, to be honest with you, there's not much modifications in certain types of problems we use with P-norm and Q-norm, but then there are in some others. So, all right, guys, enough of that. What does P-norm do for you? P-norm will require you to put in 3 values. The second values are always the same. It's going to be the mean and the standard deviation. And P-norm is the value you want the percentage below for. Now guys, let me make a point of this. Whatever value we put in here, it's going to give us the percentage below. So for example, let's say I was looking at ACT scores, which have a mean of say 20.6 and a standard deviation of 5.9, and I want the percentage of ACT scores below an ACT of 20. Then all I have to do is just put 20 in there, and put in the mean and standard deviation like I've done here, and I get my answer. The caveat to this, or the confusing part, comes, well, what happens if you want above, and what happens if you want between? So let's talk about that a little bit. Okay, so let's change from below 20 to above 20. Now again, below 20, what would we do? P-norm, 20, whatever the mean and the standard deviation are. Above 20 is doing what? Well, in this normal CDF, when we come in here at a value of 20, P-norm gives me the percent below, but I want the percent above. Well, guys, remember that the value under the entire curve is equal to 1, So all I have to do to get the above is come in and take 1 and subtract the area below, and I get the remaining area, which in this case is above 20. So guys, what would be the command? 1 minus P norm 20, the mean and the standard deviation. All right, simple enough. So below 20, plug and chug. Above 20, 1 minus, plug and chug. Okay? Now the second part is a little harder. So what if we want to change from below 20 to between 20 and 22? Well, it's going to help to look at a drawing here, and that's what I'm going to do. I'm going to look at just a little picture here. So if I go from 20 to 22, then I need that area right there. Now, how am I going to do that? Well, what I need to do, if you can think about, there's multiple ways to do it, but obviously we want to find what's the simplest. It looks like to me that if I could draw a line right here and find the area all the way down to here, all I'd need to do to isolate just that part is come in and subtract out the area from there to there. So how am I going to do that? I'm going to take P norm, my biggest number, and then I'm going to subtract out P norm, my smallest number. Make sense? It should. It's just really, from this graphical illustration, I think this makes total sense. So this value right here is going to give me from 22 all the way down to negative infinity. But I don't want from 22 all the way down to negative infinity. I want from 22 to 20. So if I come in and subtract the area below 20 in this case, it's going to isolate the area that's right there. Okay, so this is the 3 types of problems you'll have. Below 20, plug and chug. Above 20, 1 minus, plug and chug. And then between 20 and 22, you'll take P norm of the biggest number minus P norm of the smallest number. So you can see how this illustration kind of reminds you of the normal CDF key that we have on our calculator. Or at least I hope it does. So again, remember, there are going to be numbers that go in here, and I just used mu and sigma because it's the symbol for the population mean and standard deviation. All right, gang, let's talk about the other command that we have, this replacement for inverse norm. Which is Q norm. All right, so what Q norm does is it finds, now let me back up here. The key that we just looked at, that I just taught you, is P norm, and it finds anything that starts with a P, a percentage, a percentile, probability, a proportion. Q norm finds a score. This finds a percentage or a probability. This finds a score. So, for example, if I have a distribution, a normal distribution here, and it must be normal, hence the NORM, and I've got a score here, and I don't know what it is, but I know that 20% of the distribution falls below it. So I don't know what the score is, but I'm given the percentage or the probability. Then gang, the Q norm key is for you. So what I would do here, the Q norm key has, again, 3 things. And it works exactly like the inverse norm. Exactly like the inverse norm. Let me repeat that. Mean and standard deviation go in the 2nd and 3rd place. And the percent below goes in the 1st place. Now guys, this percent has to be as a decimal. So for this illustration up here, we have 20% below as a decimal. 0.20, put in the mean and standard deviation of the distribution, and you got your You got your final answer. All right, gang. Really, that's it. I want to work through. The illustration on R. I got some problems that I want you to look at. So let's bring that up real quickly. So what I've already done is I've already got it kind of going. And again, demonstration. Do not, unless you just wake up and you just decide, you know what, I'd like to get a big old 0 on my R assignment number 3. Then take these screenshots and submit them. This is not what you're doing. Okay, this should be 1 through 5. And this should be 6 and 7. All right. So let's just work through this. How would we do these problems using R? So now, one cool thing about these types of problems, and I think one thing that makes it easier, is we're not dealing with a data set. So we don't have to do any set your working directory or get your working directory, anything like that, because again, we don't have a data set on our desktop, so we don't have to reset our working directory. These problems we can just we can just do it, just get it done. So the first problem, calculate the probability the randomly selected student has SAT above 600. And guys, right up here you can see that the mean of the SATs and the standard deviation of the SATs is given. So this part right here is the mu, and the standard deviation, of course, is the sigma. So calculate the probability the randomly selected student has above. Critical word there, above. So how do we do that? 1 minus P norm, the value, the mean, and the standard deviation. So the answer would be 0.362. Now that's all you need to do when you're working these problems, because you're ultimately going to work these problems take a screenshot, and I'm going to match them up. So you just make sure you do them in order, because if you don't, you're going to miss them, because I'm going to, like the first answer I have here, I'm going to assume goes with the first problem. The second answer you have, I'm going to assume goes with the second problem. So if you get in a situation where you get off or you don't know how to do a problem, for example, let's say I come in here and I'm like, shoot, I don't know how to do number 2. I'm going to come in here and say number 2 with a hashtag I don't know how to do. So that way I'll come in and I'll just take off for that problem, but it won't throw the rest of the problems off. But guys, I do know how to do number 2, so let's do it. Calculate the probability the sample mean SAT from 50 students is below 595. Now guys, this is a central limit theorem problem, because we're not taking the students one at a time. We're taking them in groups of 50 at a time. So I see here that first of all we have a below problem. Those are the easiest because I don't have to use 1 minus P norm. So I know in this problem all I have to do is just do the P norm, put in the value of the mean, put in the mean of the distribution, and put in the standard deviation of the distribution. Now, guys, remember from my illustrations before, the standard deviation changes to the standard error when we're looking at the probability of a mean versus the probability of one person. So guys, I would have to account for that and go square root of 50. So guys, the answer there would be 0.985. All right, number 3, find the minimum SAT that places a student in the top 5%. So guys, this isn't a P norm because I'm not looking for a percentage, I'm looking for a score. So this, I'm going to use Q norm. Now, what do I put? Do I put 0.05 there? No, because the top 5% would have 95% below it. So the Q norm has tunnel vision. It's looking at percent below. So in this place, I would put 0.95, the mean, and the standard deviation. All right. So guys, you would need an SAT of about 740 to be in the top 5% or at the 95th percentile. Number 4, find the maximum SAT that places a student in the bottom 15%. Well, bottom 15% says go for it. That's percentage below, so we can just put in the 0.15. So for someone who has an SAT of 450, you are at the 15th percentile. So you are at the highest score that places you in the bottom 15%. All right, calculate the probability that a randomly selected student has an SAT between 580 and 600. What's this? Well, percentage problem, so it's going to be P norm. And guys, remember how we do that is we do the big number minus the small number. You know, I think these are easier than the calculator. I really do. Hopefully you agree with me. So guys, the probability between 580 and 600 is only about, probability 0.071. So only about 7% of the SATs are between 580 and 600. All right, now problems number 6 and number 7 are a little tougher. Let me get out of this and go back to the presenter and do a little bit of teaching. Now, guys, remember from our, from previous teachings, our categorical problems are different. So for quantitative, remember, the mu is the mean, and standard deviation is given as sigma. Now, this is for n equal 1. When n is greater than or equal to 2, then we change the standard deviation to the standard error, and sigma divided by the square root of n. Now, all of this completely changes when we get into something's categorical. And what is the key? What is the focus when you see something that's categorical? In other words, when you see a problem, what triggers to you that you have a categorical variable? What you're measuring is given as a proportion or a percentage. When you read a problem, it says the percentage of people who voted for Donald Trump, the percentage of people who didn't vote, the percentage of people who are, whatever it may be. When you're given a statement on a percentage, then you have categorical. Why? Well, go back to the Donald Trump. You either voted for him or you didn't. Percentage that are male, you're either male or you're not. Percentage who are female, you're either female or you're not. Percentage of people who own a white car, well, you either own a white car or you don't. So guys, for these types of problems, remember the mean of the distribution is P, the percentage that you're that describes the population that's categorical, and the standard deviation is P times 1 minus P over N. Now, guys, sometimes people get sloppy here, and I see it happen every time, and I teach this, and I teach it, and I teach it, and I teach it, go over and over and over, and people still do it. They want to get sloppy and rewrite the rules and formulas of mathematics, and they want to write it like this. If you wake up tomorrow and you're doing your R assignment or any assignment for statistics, and you decide you want to get all your problems wrong, then use this formula. You go get them wrong. If you want to get them right, use the one I'm giving you. Don't be changing my stuff, okay? This is wrong. This is right. That is ugly. Don't use it. Unless, of course, you just want to flunk statistics. Then use it. Rewind and use this right here. You will not get them right if you use this. Everything, the P times the 1 minus P over N, all this has to be under the square root sign. Okay? All right, gang, let's do some problems. There's only 2 of them. So, calculate the probability that more than, so guys, more than means I've got to do 1 minus. And I know it's probability, so I know I have to use P norm and not Q norm, that more than 70%, what's the mean? That's the value from the problem. What's the standard deviation or the standard error? Square root of the 0.69 times 1 minus 0.69. Guys, I could do that in my head and see it's 0.31. If you can't, then, pick up your calculator and take 1 minus 0.69. So divided by the sample size, right here where I'm circling, I hope you can see that, it says the sample's 1,000. So guys, your answer would be 0.247. Problem number 7, calculate the probability that less than 60%. So guys, this is a less than problem, or below, so I use just the P norm and not 1 minus the P norm. So I have 0.60. The mean is 0.69. Square root of 0.69 times 0.31 divided by not 1,000, but what, 850. Different problem, different numbers, so I have to do it differently. Now, what's the answer here? It looks like the answer, you might say, well, the answer is 0.699. No, it's not either. We're looking for a probability. Probability has to be between 0 and 1. This 0.009 says I have to move this decimal place 9 places to the left. So the answer here would technically be 0.1234567 699,784. So guys, to get 60% of the random sample of 850 who are overweight would be very, very, very rare. In fact, what is that? So you got tenths, hundreds, thousand, 10,000, 100,000, million, 10 million, 100 million, a billion. So about 7 in a billion chance of that. All right, gang. I'm done. Your assignment, you'll know it's your assignment because it'll just have our assignment number 3 right here, and it won't have demonstration video. Will be posted, and the due date will be clearly indicated. So get that to me on time. You don't want to lose that 50% because it's turned in late. So, guys, have a good one.